Hello students. So today we will learn about few concepts about kinematics. We will at the end of this lecture you must be able to understand the concept of rest and motion, and you should also be able to understand what are the different types of motion. So let's start the lecture. So when a body is at rest, how do we define rest? An object is at rest if it is not changing its position in reference to its neighboring. Similarly, an object is in motion if it is changing its position in reference to its neighboring. What does it mean? Let's have a look at an animation. So, okay, now here we have a little girl sitting on a skateboard, and then there is a robot. So, my question is the girl at rest or in motion? I mean, in other words, is she moving or not? So, I know your answer that you will say no, she is at rest. But my question is, how do you know that she is at rest? Okay, if we can try to understand what happens if she is moving. So I give a command to this robot on the left side that give a little push to this skateboard, and then we will see what happens. So, okay, Mr. Robot, please give a little push to this skateboard. No, maybe a little more. Yup, that's okay. And now, please just stop. Okay. So please just stop. Yes. Now if I ask you the question, is she in motion or is she at rest? You will immediately tell me she is in motion. But how do you know that? So now I tell you the reason. You know this, that she is in motion or she is moving, just because she and also the skateboard on which she is sitting right now is changing position with respect to its surrounding. And what is the surrounding? Maybe this path on which she is going, because these rectangles on the path, they are moving towards the left. So that's why you get a perception that she is moving towards the right, because she is changing her position along with the skateboard with respect to the path she is on. And you can see these rectangles on the path that they are moving towards the left. But this is not the only clue that you can find she is in motion. Just see the clouds. They are moving towards the left. And then the mountains behind her, those mountains are also moving towards the left. So that's why you get a perception that she is moving towards the right side. Hence, the definition of the motion, that if an object is changing its position with respect to its surrounding, it's in motion. And if she is not changing its position with respect to her surrounding. For example, the path. Path is here, she is here. She is not changing along with her skateboard. They are not changing the position with respect to this. See the cloud. Cloud is also there. There is no motion. At least they are not changing their relevant positions. Mountains. So that's why you say she is at rest. And when she is moving, you know why she is moving. So now you know the concept of rest and motion. Okay, fine. So now you know what is rest and what is motion. So let's move forward. Now we will study types of motion, and I tell you that basically there are three types of motions. But the first motion is translatory motion. And then we will study two more types of motions. Translatory motion is either linear, or it's random, or it's circular. All these three types of motions are translatory in nature. So the first type of motion is translatory, and translatory motion has further three other types of motions which belong to translatory motion. One is linear, other is random, and third is circular. And let me show you an animation to explain these motions. Here we have a ladybug, and let's see how does it move. Okay, it is moving, it is going straight, and I can see a line, mean the path followed by the ladybug, and I can see that that path is a straight line. Did you see? And then it bounced off this edge, and now it is going this way, and still this path is also a straight line. And now it will bounce again with this edge, and let's see what happens. So it's going, okay, then it bounced again, but every time it follows a straight path. I mean, if I trace the path with the, if I trace that path, it's a straight line, right? This one, the first one, straight line, then after bouncing off this side, it went again in a straight line, it bounced off at this edge, it again followed the straight line, and then after bouncing this edge, it is going this way, and it is also a straight line, I mean the path followed by this ladybug. So this type of motion is linear motion, and linear motion is a type of translatory motion. You already know that. Translatory motion has three subtypes. The first one was linear motion. So this is the linear motion. I mean, whatever happens, it always follows a straight line path. Now, then what is circular path? Let's have a look. Okay, so now ladybug is moving, but now this time I feel like the motion is different, don't you? The motion of the ladybug is different now. Ah, because if I trace the path of the ladybug, it makes a circle. Okay, this motion is different, right? You have seen the first motion. Now she's behaving differently. I mean, her motion is different. Because if I trace the path of the ladybug, that path is a circle. That's why we call it a circular motion. And circular motion is a type of translatory motion. This is circular motion. If a body is moving and the path of the body, path followed by the body, makes a circle, it means the motion of the body or object or whatever it is in circular motion. And circular motion is a type of translatory motion. Okay, wait a minute, then what is random motion? Because random motion is also a type of translatory motion. Let me do that. Okay, so I take the control of the ladybug and let me clear out the previous paths followed by the ladybug and let me give it a velocity. Okay, but oh, what am I doing? Okay, this is, oh, what's happening? So can you tell me what is this path or what is the type of this motion? That is random, right? Because do you find any type of pattern or order in the motion of the ladybug? No, it's just random. There is no pattern, no order. She's just moving like crazy. Such type of motion are similar to this one is random motion. In the random motion, there is no order. It just goes like crazy. So all of these three types are examples of translatory motion. So these were the example of translatory motion. And you have seen what is a linear motion, what is a random motion, and what is a circular motion. So let me ask you a question. And my question is, we have seen this animation before when I was telling you about rest and motion, and of course we know she is not at rest, she is in motion, she is moving. But now I have a different question, that in reference to translatory motion, and translatory motion has three other types of motions, for example, linear motion, random motion, and circular motion. So my question is, what is the motion of this girl on the skateboard? Her motion is linear, circular, or random? Can you tell me what is the type of motion? Of course, I know it is a translatory motion. I know that. But then under the translatory motion, there are three more types. So what type of motion she has right now? Is it linear, circular, or random? Give me the answer. It's linear. Now come to the second type of motion. You already know the first type of motion, that was translatory motion. Second type of motion is rotatory motion. And what is rotatory motion? If something is spinning around its own axis, it has rotatory motion. What is rotatory motion? If something is spinning, have you ever ridden a bicycle before? If yes, then have you ever wondered what is the motion of the wheels of the bicycle? Hmm, wheels of a bicycle, they spin when you are riding a bicycle, right? So that type of motion is rotatory motion. And I think it's easy to explain. So in this animation, I know the motion of the skateboard and the little girl on top of it. Their motion is linear motion, and that motion belongs to translatory motion. But just focus on the wheels of the skateboard. What you think is the motion of the wheels of the skateboard? Although the motion of the skateboard as a whole is linear motion, but just focus on to the wheels of the skateboard. What is their motion? Of course, they are spinning around their own axis. And you see, that motion is rotatory motion. So this is all about rotatory motion. Now let's move to the third type of motion, and it is vibratory motion. What is vibratory motion? This is repeating motion of a body along a mean position, is vibratory in nature, right? So if a body is repeating its motion, and usually that repetition is along a mean position, it goes to the one side of the mean position and then it goes to the other side of the mean position, and every time it crosses the mean position, whenever it changes its side, it always passes the mean position. And let me show you some examples. Here I have a pendulum, and what happens if I displace this mass which is hanging at one side of towards the right side? So what do you think will happen? So I displace this mass and now I suddenly leave it. Okay, so what do you think is the type of motion of this pendulum? Okay, so yes, there is a mean position, this dotted line, it goes to the right side and then it goes to the left side, and it is repeating its motion, right? And every time it passes through the mean position, whenever it changes its side, it always passes through the mean position, which is at this dotted line. It goes to the right, left. It's just, it is repeating its motion. So motion of a pendulum is vibratory in nature. I can give you another example of vibratory motion. Here I have a spring, and let's see what happens if I attach a mass at the end of the spring and then I just push it downward and then I will leave it. Oh wow, it's a beautiful motion. And what do you think is the type of this motion? You see, it is repeating its motion, and then there is a mean position somewhere around. There you can see my pointer. So that mean position is somewhere there, and then it goes up and down, up and down. And of course, every time it passes through the mean position, whenever it goes up and down. So this is also a vibratory motion. So can you figure out another example of vibratory motion? So this is all about vibratory motion. I conclude this lecture. We have talked about rest and motion. And do you know what is rest and what is motion? If a body is changing its position with respect to its surrounding, it is in motion. If not, it is at rest. There are three types of motions. And let me show you the names. Translatory motion, and then we have studied that there are three subtypes of translatory motions: linear, random, circular. Then we talked about rotatory motion, and you know what is that type of motion if something is spinning around its own axis. And lastly, we studied about vibratory motion. If a body is repeating its motion about a mean position, that type of motion is vibratory. And that's all. I hope you understand the concepts. Go back, read your textbook, and I am sure you will enjoy reading the textbook now because you already know the concepts about those things and you can imagine the motions.